Good morning, my friends. I'm Clover, and this is Genuinely Approachable Sudoku, and today we're solving Fallin by Newman. This is a diagonal Sudoku. So we have normal Sudoku rules, replacing the digits 1 through 9 once each in each row, each column, and each outlined 3x3 region. And on top of that, we have two blue diagonal lines marked in the grid. And along each of these lines, we also have to have the digits 1 through 9 once each. So for example, we already have a 4, 5, and 6 along this main diagonal, so we cannot place a 4, 5, or 6 anywhere else along that main diagonal, and we're going to have to place a 1, 2, 3, 7, 8, 9 somewhere on that diagonal. So the thing that stands out to me is we've got this 1 and 2 up here, which tell me that 1 and 2 have to be in those cells, and then we've got an 8 and 9 up here, so 8 and 9 are going to have to be in those cells. And actually, we can do a little more with that diagonal right now. If you notice, there are two 3s here, and there's a 3 here, telling us that 3 in this region is in one of those cells. In other words, 3 is not on the diagonal in those cells. So 3 has to be on the diagonal down here, meaning this diagonal is 1, 2, 3. And similarly, this diagonal is our 3 remaining digits, 7, 8, 9. We can simplify that a little bit. This can't be an 8, that can't be a 7, that can't be a 2, that cannot be a 3. And one of these is going to have to be a 7. Okay, so next step. The other thing I noticed pretty quickly trying this out for the first time is I have two 4s here, two 6s here. I've got 4s there and also a 4 here, which eliminates 4 from all of these cells in region 6, placing a 4 right there. And that is going to give me a 4 here, because that's the only remaining position for 4 in region 9. I have these two 6s and then a 6 here. This is now the only position for 6 in region 4, and therefore this is the only position for 6 in region 1. That means the last 3 remaining digits in region 1 are going to be 3, 4, and 5, like that. And the last 3 remaining digits down here are going to be 5, 6, and 7, like that. Okay, 5 and 7 can't go in these cells in the column. So there's either a 5 or 7 here, and a 5 or 7 here. It's a 5-7 pair. But because we already have a 5 on this diagonal, this is going to be our 7, that's going to be our 5, which resolves these 3 digits. Same thing going on here. We can't have a 3 and 5 in these cells because they're already in the region. So this is going to be a 3-5 pair, but because we have a 5 on the diagonal already, that's our 3, that's our 5, and those 3 cells are going to resolve. Now what? So we can pencil in a 1, 3, 9 there for the rest of the column, and a 1, 7, 9 there, and we can simplify that just a little bit. We can't quite resolve them yet. If we look at 6s on the right side of the grid, we have a 6 here as well. So all of these cells are seen by 6s, so that's going to be a 6. And then if we look at 4s on the left side of the grid, this is the only position for 4 in region 7. So our remaining cells in this region are going to contain 1, 2, 5, and 9, and that cannot be a 1 or a 5. This can't be a 5 because of the diagonal, and also this can't be a 5, so that's our only position for 5. Very similarly, up here, the only position for 5, it can't go in row 1 because there's a 5 there. Can't go right here because there's a 5 there, and it can't go in the diagonal, so it must go right there. Meaning our last 3 digits are 1, 8, and 9. That can't be a 1. This cannot be a 9. Now if we look at this row, we need to finish it off with a 4 and 7, which will go like that. And in this row, we need to finish off with a 3 and 6, which will go like that. And these two cells are going to contain 1 and 9 to finish the column. That gives us a 1, 9 pair here, which places a 3, which resolves all of these, and bounces back and resolves just about everything else in that area of the grid. Now we know this is going to be a 9 because there's an 8 in the row now, and this is going to be a 1 because there is a 2 in the row now, and I can eliminate 1 from here and 9 from those two positions. So this is now either a 1 or an 8. My digits here are going to be 1, 2, or 8, and that's not going to be a 1. That's got to be either a 2 or an 8. And over here I have either a 2 or a 9 there, and these are going to be 2, 8, or 9, and that's not a 9. That's a 2 or an 8. So now I have this lovely 2, 8 pair on my diagonal, which resolves this into a 1 and resolves this into a 9. And it's going to give me a 9 over here. And now I have a 1 over here and an 8. So let's finish off. So we need a 3 and 7 in this region. They'll go there and there. Up here, I'm going to need a 6 and an 8. They'll go there, and that will actually resolve my 2s and 8s very cleanly. Okay, and here I need a 5 and a 9, 5, 9 right there. In this row, I'm going to need a 1 and a 5. And in this row, I need a 2 and a 4. And that is how you solve Philip Newman's Free Fallin. Hope you guys enjoyed that one. The link to solve it yourself is in the description of this video. And I will see you again in a few days.